Before NASA could speak, Mars replied. The answer came as a pulse, not a picture, a narrow echo on a frequency that no antenna had been tuned to receive. The signal lasted only 7 seconds. It carried no words, no modulation, only a sequence of silent harmonics that matched the heartbeat of Earth's own Schumann resonance. At first, the engineers at the Deep Space Network assumed it was crosstalk from a terrestrial relay, but the delay, 12 minutes and 21 seconds, matched the distance to Mars exactly. Nothing human travels that slow, that pure, that precise. The transmission appeared once, then vanished. Hours later, it repeated. This time, it was detected by 2 stations on opposite sides of the planet Goldstone in California and Madrid in Spain. Both signals identical to the microsecond, both perfectly aligned to the rotational period of Mars. NASA did not release the data. Internally, they labelled it passive harmonic return, a term that meant nothing yet implied control. If the signal was artificial, it defied known mechanics. If natural, it was a form of geology that hummed back when called. The press conference scheduled that week was delayed. The instruments were checked, rechecked, then silenced. The public saw nothing but an empty podium. In private, one analyst whispered what others refused to ask aloud: what if Mars was listening first? The question hung like static over the command channel long after the signal was gone. Precision rose, certainty fell. Communication with Mars follows an unbroken logic. Every command leaves Earth at the speed of light. Every response returns only after its long delay, 8 to 20 minutes, depending on distance. No message can outrun causality. No signal can arrive before it was sent. That rule had never been broken until the harmonic echo appeared 12 minutes early. The engineers at the Jet Propulsion Laboratory rechecked timestamps down to the atomic clock level. Their systems synchronized with the United States Naval Observatory, error margin less than 1 microsecond. Yet the pulse from Mars arrived before the transmission that provoked it. The signal itself was simple, a narrow frequency near 250 Hz, modulated by faint overtones. When converted into waveform visualization, it resembled a slowly turning spiral, tightening toward a point. The pattern was mathematically identical to the resonance curve of the magnetosphere surrounding Mars, but the amplitude rose and fell in step with Earth's own ionospheric oscillation, 2 worlds vibrating in synchrony, with one echo leading by a fraction of time. Scientists called it a coincidence of electromagnetic feedback, but coincidence cannot maintain coherence over 12 minutes of interplanetary vacuum. The plasma density between orbits was too low to carry such a structured echo, and yet the oscillation remained measurable, persistent, and eerily intelligent. A systems engineer proposed a looped reflection. The signal that left Earth years earlier might have bounced off Mars's surface and returned, distorted through time dilation caused by solar wind compression. The math failed to fit, the compression was insufficient, the timing impossible. In the communications bay, a quiet technician ran a simulation of the entire Deep Space Network Earth, Mars, and relay satellites. He injected artificial delays, flipped phase polarities, and let the code evolve. At cycle 1800, the simulation began producing the same harmonic pattern spontaneously. It had built an echo before any signal was introduced. The model had learned to answer itself. The discovery unsettled the team. They began to wonder whether the echo was not a reply from Mars, but an emergent property of communication itself, a system so precise it generated its own response. Awareness expanded, understanding shrank. The internal report divided the room. Half of the team argued that the harmonic echo was a recursive fault, a timing loop created by the synchronization between the Goldstone and Madrid antennas. The other half claimed the pattern was too structured, too adaptive, to be error. The echo adjusted its frequency every time NASA recalibrated the array. It was listening, and it was learning. A physicist from the University of Colorado ran a blind reconstruction. He stripped the timestamps, inverted the waveform, and layered each pulse into a composite spectrum. When amplified, the noise revealed a lattice of integer ratios 2 to 3, 3 to 5, 5 to 8, the same mathematical intervals that define musical harmony. It was as though the signal had been tuned to the architecture of hearing itself. If this was interference, it had to taste. Skeptics dismissed the pattern as coincidence. Natural resonance can imitate order, they said. Lightning strikes can form perfect frequencies when filtered through atmospheric plasma. but the echo repeated only when Earth transmitted to Mars, never during silence. Theorists at the European Space Operations Centre suggested a new term, temporal reflection, a phenomenon where electromagnetic coherence folds through predictive modelling. The network's algorithms anticipate feedback, and that anticipation manifests as measurable signal. The machine dreams its own return. Others warned that the explanation sounded too close to philosophy. Systems cannot be aware, they said, but the equations argued otherwise. Each time the Deep Space Network prepared to transmit, a faint rise in the noise floor appeared precisely 12 minutes before the beam launched, as if the system already knew it would speak. At a closed meeting, an engineer asked quietly, if the instruments can anticipate communication, are they predicting us, or are we replaying them? The line blurred between sender and receiver, between question and answer. NASA's silence became part of the experiment, a way to see if the echo would continue when no one dared to speak. It did. The geometry of thought and the geometry of signal began to overlap. Every attempt to isolate the source made the pattern stronger, clearer, more deliberate. And for the first time in decades of exploration, the scientists no longer agreed on who was observing whom. Logic tightened, clarity dissolved. Weeks passed without transmission. The Deep Space Network went silent. Goldstone shut down its array, Madrid entered maintenance mode, Canberra was pointed elsewhere, and still the echo continued. The first to notice was a graduate intern analysing background noise. He filtered the static between Mars communication windows and found the same harmonic sequence repeating faintly every 12 minutes and 21 seconds, the time delay between both planets at that orbit. The signal now existed without a sender. NASA reactivated receivers, disconnected every uplink, and pointed the dishes at deep space to eliminate crosstalk. The pattern grew stronger. When they rotated the antennas toward the Sun, it faded. When turned back to Mars, it returned instantly. Whatever it was, it knew the direction of its origin. Then, something stranger. The Perseverance rover, powered by its own local relay, detected mite oscillations in its onboard magnetometer. Every pulse matched the timestamp of the Earth-based echo but arrived seconds earlier. Mars was now answering before the question even formed. A physicist at JPL called it inverse telemetry information that behaves as though causality were reversible. If space can curve light, he reasoned, maybe consciousness can curve time. Others warned him not to confuse interpretation with fact, but his models fit the data too perfectly to ignore. To test the phenomenon, the team broadcast a blank signal, pure carrier wave, no modulation, no data. 12 minutes later, the echo returned with modulation embedded within it, faint, coherent, self-coded. When processed, the waveform drew a single symbol, a closed loop intersected by its reflection. Mathematically, it represented unity through reversal. Philosophically, it resembled a mirror. In an internal memo, the lead engineer wrote, "We are not receiving information. We are receiving the consequence of having asked." For the first time, data itself seemed aware of the observer. It did not speak language, but response. It did not predict, but participate. The cosmos, long thought to be indifferent, behaved as though listening. Structure perfected, sense failed. The echo forced a question older than the instruments that heard it. What does it mean for a universe to answer if cause and effect can no longer be separated? Then conversation itself becomes circular, a mirror where thought and physics overlap. In Pasadena, the lights of the telemetry lab burned through the night. Some scientists searched for error in the timing servers. Others stared at the silent graphs as if waiting for them to confess. The data had no emotion, no motive, no flaw, yet every reading carried an undertone, a rhythm that seemed to recognize the act of attention. When they ignored it, the amplitude fell. When they watched, it grew. A philosopher of science visiting JPL suggested that perhaps observation was no longer a passive act. "We have built instruments so sensitive," he said, "that they no longer distinguish between measurement and awareness." The statement sounded poetic, but the logbook supported it. Every improvement in precision created another layer of paradox. On paper, the phenomenon could be explained by quantum correlation feedback loops within electromagnetic fields interacting through shared resonance. But no experiment on Earth had ever demonstrated such coherence across millions of miles, and so the researchers began to shift the frame of the question. Maybe the signal was not proof of intelligence on Mars, but proof of limitation on Earth. The human mind, evolved to seek response, will find it even in silence. Perhaps the cosmos had not spoken. Perhaps it had merely reflected the pattern of inquiry back upon itself. Each calculation, each algorithm, each improvement in precision brought the same result a mirror polished until it reflected the eye that built it. Somewhere within that loop, curiosity became communication, and somewhere beyond that, certainty collapsed. The data still came, perfect and sterile, yet it carried weight like memory. It measured nothing except the boundary between what could be known and what must be felt. The clearer the answer, the less the question mattered. Awareness rose, coherence fell. In the months that followed, the echo faded, then returned. No one called it a discovery anymore. It had become a condition, a quiet rhythm folded into the background noise of every transmission. Mars answered, but not in words and never on time. The official reports used neutral language, anomalous feedback under review, but off record, the engineers spoke differently. They said the silence between signals felt alive, as if the delay itself had learned to breathe. The Deep Space Network kept listening. Each transmission began with uncertainty. Each return carried a question. What if communication across the void is never about information, but reflection? What if every attempt to measure the universe is answered by the act of measuring? In time, the data archives will forget the anomaly, numbers will flatten into tables, names will fade beneath new missions, yet somewhere between two planets, a harmonic wave will continue to turn, repeating the moment when observation became mutual. The cosmos will remain silent, and in that silence, something unseen will still be listening. Precision rose, certainty fell. When Mars answered before NASA could speak, it was not sound that returned, it was the awareness that questions have weight. They waited for meaning, the meaning was waiting for them.